Assalamu alaikum warahmatullahi ta'ala wabarakatuh, ladies and gentlemen. Welcome back to another live stream. Alright, so let me share the live stream. My Discord server, please join my Discord server so you can get notified, new live streams, and also you can vote for the next one. So, everyone, let's go. Hi. Let's go. Hold on a second. Okay, I think we're all good now. I think we're ready to start our journey. Once again, I wonder if the live stream is fine. Is the quality fine? Is everything great? I mean, it seems to me good here. So let's get started, I think. Let's get started. Okay, so like last time we basically I was stuck in MSAA, like multi-sampling. But I finally fixed it off camera. So if we debug this, hold on a second, what's going on here? Let me make sure I'm in the right place. So git MSAA. I just create another branch. Let me make sure I'm in the right branch. Cannot check out because of merged files. What? Merge, port merge. Oh, I see what's happening there. Okay, let's go to MSAA. Let me check out. And yeah, let's try to run this. Let's go. So there you go, it actually works. And now you cannot really see the pixels anymore because it's multi-sampled. It's very smoothed out pretty much, which is lovely. So the fix was actually quite simple, but I'm gonna show you what I have changed so far. And there you go, as you can see, I have like MSAA X8, basically 8 samples. Let me show you what I have changed so far, and then we can merge it into main so we could continue our journey. So MSAA, we are here, I think. Okay, let's see master, show def, show compare with MSAA, okay. And let's see, commit, swap chain fix, MSAA draft. What else? Well, show def would work in tree with master. There you go. Okay, so this is what I changed. Let's see. Okay, there you go. So the first thing, we have a new variable called samples, which is basically type 8. Of course, I'm using dynamic rendering just in case. Okay, so size, this is not very relevant, whatever, as long as it fits for our buffers. Okay, what else? What is very important here? There you go. Okay, so rasterization samples, multi-sample state. Okay, so I think this is the base version. All right, I see. So this is the old version and this is the new version. So the old version, it was like 1 sample here, but right now it's using that variable, which is 8 samples right now. And the other thing is from ref. Now, honestly, this is not important. It could stay the same. I just had a problem before, but right now, like, just there's no need to actually change this. This is fine. This is also fine. What else? Okay, so here we have created a, well, not created, but at least made some variables. MSAA image, MSAA image view, MSAA image allocation, and image extent. Okay, great. Let's go down right now. Okay, so first of all, I actually had a big bug, a very bad bug, which is the fact that I forgot to toggle back the should recreate swap chain flag. There you go. That I basically used to actually. So it basically once it started to try to recreate the. Well, it basically every frame it was actually trying to recreate the swap chain, which ended up with memory with out of memory. So this fixed it, of course, because well, right now I'm toggling it back, which is the actual correct behavior. I just forgot to do so. The other thing is, yeah, I just brought back this service capabilities. I removed it from here and I put it, I guess, up there. Yeah, here, up here, not inside of the swap chain scope. And then we also have, can I actually unify this? Hold on. There you go, unified viewer. Oh my God, this is gonna be much nicer. Okay, let me see. Hold on. There you go. So should recreate swap chain equal to false now? Okay. Now let's surface capabilities. There you go. I just brought it from there to here. And then I'm basically replacing image extent with the new extent. Okay. And then we also get in the, let's see, image extent, current extent. But okay, great. What else? What else? What's new? Destroy swap chain, blah, blah, blah. Create image view. Okay, so this is what's new. First of all, when we want to recreate the swap chain, we destroy the old image, the old MSAA image. We also destroy the old MSAA image view. And then we create a new MSAA image, basically create image, blah, blah, blah. The only thing that is special here is samples, I think, and also transient. This is for MSAA images. And also there is, well, here we're creating memory, we're getting the memory requirements of that image, then we're allocating for it some memory. And notice that it's not linear. Best performance probably is linear false, though I'm not sure about that. But there you go. Also, it's GPU only. It's inside of VRAM, not in RAM or shared memory or whatever. And other than that, you're binding the image memory. Then we're creating an image view for that MSAA image. Nothing too special here. And for each image, okay, so that's not new. And I think that's, oh yeah, we also have another pipeline barrier, so we could actually go ahead and convert the layout of the MSAA image to color attachment, to attachment optimal, basically, because we need that, just like the swap chain image. And here, now this is what's we had before. The problem that we had before is the fact that I had two attachments before, which was correct for render pass, but not correct for dynamic rendering. So, and in fact, it's much more intuitive and cleaner right now. So you just have one attachment. The image view of it is the actual MSAA image. So basically, we're going to be rendering to the MSAA image. And here, of course, we're cleaner at the start store, just like before, basically. But image layout, color attachment optimal. And yeah, this is what's new here. Resolve image layout, color attachment optimal, and resolve mode average, and resolve image view, swap, and we're basically resolving to the swap chain image, so we could present that. Of course, the swap chain image is one samples. So yeah, color attachment from ref. Swap chain image views. This is very weird. Okay. Hold on. Kind of confused there. Yeah, this seems about right. And then the width. Now, instead of using the window side, which I was doing before, right now I just made the image extent in another scope, in a much wider scope, and I'm just using that instead every time, instead of the window size, which is the correct behavior. Otherwise, you'll crash the application. So other than that, there's nothing really new, I think. Yeah, also another thing is that you would also get a crash if you don't handle error out of date in queue present here, which I've done now, as you can see. And yeah, that's pretty much it for the MSAA. So now we have some cool MSAA, very smooth stuff. I'm not sure if what is it called? Render doc works now. Sometimes it works, sometimes it crashes. I'm not sure why. But let's try it out now and let me show you what MSAA have done. So if I go here, right, open in Explorer, let me grab the executable here, target, debug, or we could go with the release. So we could go with the release, why not? So cargo run dash dash release. It's gonna compile and okay, great. So now let's actually go to target to release, and let's say Control Shift C to copy the path. Let's put it here in the executable path. Same thing in the working directory. Just make sure to remove these things, and we want the actual root directory of our project here, and then we could launch it up. Allow access. And of course the FPS have dropped because MSAA is very heavy on performance. Okay, there you go, pretty cool stuff. Now let me actually capture a frame. Let me show you how it looks. Now I could basically go here, and there you go. You can see right now that there is some transparent pixels instead of like before. It was like just straight out a line, which was very rough, and you can actually notice the individual pixels, which was very jarring. Right now I have this multi-sampling, which is making it like this, which is making it much smoother, basically. So that's pretty cool. And inputs, outputs, okay. So maybe I could show you the actual steps that is happening here. Hold on. Okay, so this is, I guess, the first step. So as you can see, the outputs, we have two things. We have the 2D color attachment, which is probably the MSAA, the multi-sampled, like the multi-sampled image, and then the swap chain image here. So this is the first step. Basically nothing is rendered yet. We have just cleared the screen, I think. And then at this step right here, when we draw indexed, we get the image in both of them. Basically, we have the image here in the swap chain image got resolved, and here, as you can see, it's x8, and it's actually much more samples. Basically, so yeah, that's I think pretty much it. Right, yeah, pretty much. So yeah, let's go back into the actual stuff. Pretty cool stuff. Okay, so actually let me first of all merge these two branches. Let's merge them together. How are we gonna do that? Well, let me make sure I'm in, well, which branch I'm in right now. Check out a master, and let's merge MSAA into master. Okay, and then I'm just gonna accept theirs, which is basically the other branch. Okay, great. So right now, as you can see, we got MSAA. The other thing that I was also doing, which was in another branch called draft. Let me show you this too, maybe. Compare with master, show diff with working tree. Okay, main.rs. Let's see this one too. So here I've just done some minor, well, yeah, some minor changes, I guess. So for example here, buffer create info. The name, I just made it static str, but honestly, come to think about it, maybe we'd like, now this would work as long as like the string is in line in the code itself, but honestly, I'm probably not gonna go with this one for now. The other thing that I've done is I removed the allocation scheme. There is no need really, at least I think. And what else? Buffer now where I'm actually storing the info struct that we get in the constructor. which would be nice. And also I'm storing the device so I could use it later on. I'll show you. Here I just switched the parameters order, nothing crazy there. And here instead of allocation scheme, I'm just using GPU allocator managed, so I can leave the GPU allocator to do its job. And here I'm just passing the device, and all right, copy from. It got an offset here, pretty much. Destination. Well, I was doing some weird thing here, so never mind about that. This is just my draft. Let me see if there is something. Oh my god, this is crazy. So device clone. Okay, so here's something that I've just managed to find, which is size of val. So instead of std_mem size of vertex times vertices.len, right now I'm just saying std_mem size of val, and you just give it the array, which is much nicer. The other thing is now, as you can see, we no longer need to give it the allocation scheme. And here we're creating a buffer, great. Size of val once again, instead of this craziness. And what else? Staging buffer, pretty cool. Size of val. So I'm just gonna keep this as a draft. I think, yeah, pretty much. And this doesn't contain multi-sampling, of course. Well, yeah. Builder, what's this? Extent average. Okay, cool. All right, never mind. I'm just gonna disregard that for now. So, okay, so we should do now. Well, let's see what we could do. Let's go to the tutorial and let's see. So I'm probably gonna go with the matrices right now, so we could have some transforms and basically transforming geometry around, I think. So shader modules, blah blah blah. So we have done that. Now it's basically the scripture layout and buffer and stuff like that. So you can basically transform geometry around, etc. So the model matrix, the view matrix, the projection matrix, etc. Though actually before that, I just remembered, I'd like to maybe try some shader reflection. Basically, if you notice here, when it comes to the push constants, where's the push constants? Push constants. There you go, push constants range. So it's basically very manual. Now there is a good crate that we could possibly use for reflection, which is called, I think, SPURV something. Hold on. SPURV reflect, RSPUR. There you go, RSPURV reflect. From the same team that have made the GPU allocator that we're using. And let's just try this and see if it would work for us. This would also help us with descriptor sets and stuff, which is very cool. Anyway, I'm just gonna see if it works. I never really tried it honestly before, so just gonna see. So RSP reflect, let's go cargo toml, let's add this into the dependencies. We have another dependency there, great. And let's see how we could use it. So let's go to grades.io, documentation, or we could look at the examples actually. Okay, go back. Let's look for the examples real quick. Tests. And then there's push constants GLSL. SPV, push constants verge. Push RS. Where is RS? GLSL RS. Okay. There you go. So basically you just say reflection new from SPURV. Then you give it the SPURV code, which we have actually compiled. Whether it's GLSL or HLSL doesn't matter. And then you can, in fact, you can disassemble it to see the instructions, but we don't need that in our case. We could also get the descriptor sets, which we're gonna be useful for us. Warning, array size defined by unbounded x. No idea is that anyways. So assert EQ. So it's checking the sets. As you can see, it can give us the name. Is it like, what is the variable name or the uniform name or whatever? It also gives us the type. Like in here, it's uniform buffer. This guy is storage image. That's the second set. Interesting. Very, very interesting. So this would very much help us automate the binding sets a bit. But later on, of course, we want to use BDA, which is like buffer dynamic address and dynamic indexing or something like that, or descriptor indexing. Yeah, exactly. So to make it even nicer. But for now, this should be good to go. Okay, push constants, let's go. This is push constants, how you get it. So reflect, get push constant range, and then you get that, and then you can just pass it to the pipeline. And we will automate it. Currently, in fact, if you look into it, let's see where I'm specifying the push constant. There you go, not this one though. Hold on, go back. There you go. Okay. So in the pipeline layout, you can see that I'm actually manually specifying the push constant ranges here. But we could actually make use of this to automate it a little bit more. It gives us the offset and the size, essentially. And then we could basically pass it here. I mean, at least in theory. So let's just compile this real quick. And seems like maybe when it have got a new version, interestingly, maybe it fixed the raw window handle, possibly. I'll have to look into that, out of like while I'm not live streaming. But anyways, so let's try to use that now. Where I'm compiling the shader. Let's look at that. Shader stage before of this. There you go. Vertex shader stage. As you can see, we're using shader C to actually compile that stuff. But now shader stages, pipeline layout. There you go. Pretty much here. We need it here. Okay, let's see. So we need to say let reflect. Or honestly, let me just copy this. Or you know what? Never mind. Reflect reflection. No, let's see. And then let's say reflection. Okay. New from Spurvy. So, oh, interesting. You could actually give it a module or the code. Let's see. I don't think it's mainly the actual Vulkan module though. Yes, probably some other module. Yeah, basically, the crate that they're using, rSpurV, I think, allows you to actually like construct shaders using using Spurv instructions at runtime, which is very crazy. For example, you could create your own compiler, your own shader compiler or something like that using this. But currently we just have the actual shader code. So let's go ahead, new from Spurv, let's give it the code, which we could actually get from fragment shader RTPK as binary. So let's say reflection. I could probably extract away this shader module because right now it's getting a bit messy. So let's say vertex shader RTPK. So as binary. The binary of that shader, and so expected U8 found U32. Hello from Melbourne, Australia. Hello, welcome to the live stream programming series. Actually, welcome back. So I've seen you in the previous live stream. Welcome. How is it going? Please rather focus on Zig, please. Currently we're just going with Rust, and honestly I kind of enjoy it so far. But pretty much, yeah, I may go back to Zig. But for now, I'd like to basically focus on one thing and just go with it for now. And Rust seems, so far, it's very much very nice. Like you could easily install libraries. As you can see, I'm dependent on all these cool libraries. I almost didn't have any problem, only with the raw window handle and winit. And right now, I think since winit just got an update, maybe that got fixed at this point. But yeah, that's the only problem that I had with libraries. Other than that, so yeah. Anyways. So here the problem that we have is that it's expecting bytes, but we oh yeah, there you go. We could tell it as a binary and that would do the trick. Let's go. Live stream quality great. Let me know. What is going on here? Let's say in wrap, and let's go. So that's the vertex shader reflection. Let's also get the fragment shader reflection. Fragment shader reflection. And yeah, let's go with this. It is stuttering a little bit. Interesting. What is stuttering exactly? I mean, the stream quality. I mean, it seems all good to me from here. Like, is it the audio, the video? Seems great to me. But let me know. Oh, actually, let me quit all this craziness. Hold on. And also, the audio. It is okay now. By the way, let me know, like, is this better or this? All right, so what about now? So right now I've just shutted down the my filter that removes background noise. But right now you're gonna hear the background noise, but at least probably gonna have much nicer audio quality. Let me know if I should get it back or not. Seems quiet for now, so this is fine. I guess. Okay, what else? Is there anything else? Seems good. I could even quit Discord, in fact. Alright, fine. So, right now, is it fine? Let me know. Okay, so we got the shader reflect. Yeah, I can hear the background. Is that better or should I enable it? Let me know. Tell me if you like it with the filter or without the filter. Let me know. So yeah. Though without the filter, you could actually hear the keyboard. Some people enjoy it, some other people doesn't. So yeah, just let me know, guys, what you find more comfortable. Pretty much. Okay, so the vertex shader reflection and the fragment shader reflection. So let's actually check this. Let's try to print this. Print this and let's see. Vertex shader reflection. Same problem. Which problem? Hold on. Right, let's see. Okay. Seems good to me. So yeah. But anyways, let's just keep going. What's happening here? The traits debug is not implemented for reflection. Interesting. Okay. Let's see what we have here. So we need the push constants. Git push constant range. What else we can do? We could even disassemble it, right? Oh, okay. Now, okay, nice. Git compute group size. And let's just see the instruction real quick, just for fun. Okay. There you go. As you can see, here's the instruction, the spurvy instructions. At runtime, we can get that, as you can see. So if we let's see, hold on. So this is the vertex shader disassembly, and this is what we got. So this is common SPIR-V version 1.0 generator R/SPIR-V bound 35 OP capability shader, and there is probably, this is a variable OP_ext instance import or something like that. GLSL STD 450. So as you can see, it's importing that. OP memory model logical OP entry point. Here's the entry point main. I'd like to eventually convert to HLSL instead of GLSL. That would also allow us to use multiple entry points, which would enable us to like merge these shaders together instead of having one shader per stage, I think. But I'm not sure. OP source extension, OP name, member name. Okay, what is this? GL position, point size. I think these are the global stuff. OP name, in position, constants. But anyway, this is like the disassembly, the SPIR-V disassembly. But we don't need it right now, though it may be useful later on for more advanced cases. Now what we really want is actually get push constant range, is what we really want here, at least for now. So this would also be useful in today's video, because we're going to be dealing with descriptor sets, matrices and stuff. And there you go. Okay, so there is some push constant and it told me offset 0, size 4 bytes, which is exactly, I think, what I have here. Hold on, where it is. Where's pipeline layout? Here you go. Which is exactly this. So offset 0 and size of push constants. And I think this would be like 4 bytes basically, because it only contains a float. So we could actually go ahead right now, instead of hard coding this, we could say vertex shader reflection. Well, in fact, shader reflection dot, well, in fact, we could just use this, right? So hold on. So, and also we're only using that, I think, in the vertex maybe. Anyways, so vertex shader constant range is equal to that, and then we could just say this. What's this? For some reason it doesn't allow that, but just say wrap. Well, I mean, it could be possible that there's no constant push constant info basically, but for now I'm just gonna hard code that. So vertex shader constant range, or push constant range, in fact. Range. Yo, what's happening right now? Weird. Hold on. In wrap. Interesting. I need it 2 times. Oh, one for the error and one for the option, basically. Right. Interesting. So, anyways, let's just say vertex shader push constant range dot offset. Nah, actually here size, and basically the same thing with this guy. Right now, just changing the shader itself will, like the push constant range of the shader would change it here, would make sure to change it here, which would allow us to make a better abstraction for shaders, because right now we have all the information beforehand. We don't have to give it. So that's very cool. Stage flags, for this one for now, well, depends basically on where you want to basically give it. For now, let's just go with vertex, I think. That's where we're taking this from the vertex though. So yeah, I think that's pretty much it for that one. But anyways, so, but I wonder how we could handle, like, for example, what's happened if you current line. Oopsies. Fragment shader reflection. Dot get push constant range. And in wrap. Dot in wrap. Push constant info doesn't implement std_fmt display. Yeah, parameter. And let's see this one. So this is the fragment shader reflection. It should be none. Oopsies. Well, I mean, I guess that makes sense. Hold on. Let's just remove this in wrap right here. Let's see what's gonna happen. What? No field size in type. Oh, well, I didn't mean here, and then wrap here. Let's see. As you can see, none for the fragments. But if we wanted to actually use, for example, the push constant in the fragment shader, then let's see what's gonna happen here. How we can do it. Vertex shader. Let's just copy this push constant to the fragment shader, for example. And let's say, for example, the red, let's say sign of time. Push constants dot time and time 0.5 plus 0.5 to normalize it. And of course it wouldn't work, but if we do, well, let's see, hold on, where is it? Yeah, if we give it also fragment here in the push constant, let's give it fragment. It takes some time. Okay, let's go. And let's see now. This should work now. Actually, it doesn't. Oh, it does. Let's go. Interesting. It becomes black. There you go. So because we put the push constants here, but okay. Well, what happens if I actually give 2 instead of 1? Because right now, if the push constants of the fragment is different from the vertex, then we're gonna have a big problem because we're basing everything on the vertex. But no, let's actually remove this and let's try something else. Let's try fragment shader reflection. Let's grab this here and let's just say let shader reflection in wrap. What? Equal to vertex shader. Hold on, let me just copy that. And let's use the fragment shader reflection instead here in wrap. Okay, great. And then basically I'm just gonna do 2 of them here. So there you go. And now this is for the vertex, this is for the fragment, I think. And this is for the, well, I forgot to actually push constant range, and let's use that instead here. And let's hope this works. And let's see. There you go, it actually works. Let's go. Nice. So now we could actually make a much nicer abstraction for the shader, because Basically, when we're going to create the shader, we don't have to actually pass it out this pipeline layout. We could just take it from the reflection of the shader, which is amazing. So it's going to be similar to OpenGL, no crazy stupid stuff. DG, hello, welcome to the live stream. Wa alaikum salam. Welcome. How is it going? Okay, I think let's just go ahead and maybe go abstract shaders possibly. What do you think? Since we have all this stuff going on, which is quite interesting. Okay, I think let's go ahead and do it. So struct shader. Okay. Struct shader. So what it's going to contain? It's going to contain a handle or a module essentially, which is going to be vk module shader module. Oopsies. Let's go. What else? What's going on here? This is fine. Okay. Other than module, what we need else? We also need, I think, a pipeline layout, isn't it? Or is it? Not really. Yeah, no. Hold on, what? Where we're creating the shaders, hold on. Vertex shader module, and let's see what we need here. So basically, you're gonna take the path in the constructor, and we're just gonna load it essentially. And hopefully, we could even maybe find the shader kind. That would be nice, I guess. Some options. We also need to get a reference to the compiler, and maybe the shader kind. As binary, none. Okay, and here we got the vertex shader stage. We could also get that from bytes with null b main module. Okay, let's just grab this. So we're basically gonna need the RTP. And what else we're gonna need? We're also gonna need the module. Okay, what else? We also gonna need the stage, maybe. Yeah, the stage. And finally, also the reflection. Vertex shader module. Then you got the shader stage, and then you got the reflection and the push constants. So let's go back now. Okay, let's just copy this here. Oops, what I've done. Okay, what? No, I've done something crazy. Hold on. Okay, until you're good. So, struct shader. Constructed. Okay. So ample shader. And hold on a second, it's very hot here. I'm just gonna open the window. Okay, back. All right, let's go. So impulse shader, fn new, and this would basically give you self, isn't it? Okay, and this in fact would be a result, would be anyhow result self, and yeah, here which is path, I think. So mismatch type expected result. Okay, so here new, we're gonna get the path. So I don't remember how do you get a path in. Let me see. Hold on. Let's just go down where we're doing it, where we're getting the shader source and stuff. So, and it's basically, yeah, as ref path. So that's something. So let's grab that and let's go up there. There you go. So this is the source of the shader, and we're gonna basically get this P, which is as ref path. Okay. In fact, let me just copy this whole thing. Okay, and let's just do this. So we're getting some path here. Import it. What's happening? There you go. And then we're basically gonna pass the path here. So now we got the shader source. What's next? We're gonna go down, and by the way, in fact, hold on, let me check if there is some crate that could process GLSL and maybe could give us some more information, like maybe the shader stage or something. I don't know, but let's just see if there is anything like that out there. Let's look for GLSL, and there is a GLSL parser. Okay, and it's kinda okay. Let's see. This crate is able to parse valid GLSL. Parsing, transpiling. This is basically parsing, not really. Basically, you could give it some GLSL, you could parse it and get an EST. Pretty cool, but you still have to compile it into SPRV though. Parsing a whole shader. So that's not really what I wanted. Really, so anyways, never mind. Okay, let's go back. Where is it? There you go. Okay, so now what we're gonna need in vertex shader module, fragment shader artifact. Yeah, we need the artifact right now, and let me just try to get this here. All the stuff that I want to copy here. So I need the module, and I also need the shader stage. I need the reflection. And also finally I need the push constant stuff. Where is it? Push constant. Hold on, what? Actually not here. And let's same thing here. Let's put it here. And what else? So we got the reflection, and we got also what? The push constant range. And finally, I think I'm gonna, yeah, we don't have any. Interesting. So let's actually also grab this guy right here. I'm gonna show you what I'm gonna do with all this. Okay. So let's just copy this stuff. There you go, here. Let's go up there. Just gonna here. Remove this. Remove this. and let's just put it here. Okay, so first thing first, next up, vertex shader. So now we need to compile it. So let's go ahead and compile it. So just gonna grab this code right here. Oopsies, there you go. So this is the artifact. Let's go. We of course need the compiler. So compiler is equal to shader C, right? Yep, compiler. But of course we're not gonna move it. We're just gonna take our reference there, and that should be fine. It's vertex shader source. Here's the source code. And what else? Shader kind. Now this we don't have this information, so we're just gonna give it. And yeah, let's go ahead and say shader stage. So shader stage would be, or shader kind. This would basically be shader C, shader kind, I guess. Let's go. And and also here there's gonna be path, and here we also need the entry point name. What's happening here? Yo. Oh, I guess maybe it needs the reference or address. Expected str found p. Okay. What about path as ref maybe, or something like that? Found path. Well, how do you get a string from this? Yeah, you could say to str, interesting. So basically as ref to str, seems like. But of course in rapid. Or not in rapid, let's just propagate back the error, if there is any error. But well, context, I don't know, invalid path or something. Okay, so additional options in resolved reference options. Yields str slice of the path is valid Unicode. This conversion may entail doing a check for UTF validity. Path is not valid Unicode, basically. And here additional options were these. Well, let's see where those options actually are. Where are the options? There you go. Let's see what options we have. So we could actually add macro definitions, set auto bind trinoforms, binding base, okay, HLSL functionality, limits. Well, that's interesting. So compile options too, honestly. So compiler and compile options. Shader C, compiler options. Okay. Or compile options. And okay, so this should give us a compile artifact. Now that we got the artifact, we could actually go ahead and create the shader module. And to create the shader module, you just have to do something like this, I think. And every time formatting runs, it just flags in. Here we need the device, interestingly. It makes sense. So let's actually give it the device. Okay. So device dot create shader module. Oops, not vacate hash here. And here we could just get the artifact binary. Seems about right. There's also allocation callbacks, which I don't care about right now. Okay, what else? So right now that we create shader module, our job is done here, I think. The other thing that I'd like to do at the constructor is maybe the reflections. Yeah, pretty much. Let's get the reflection too. So where I've done it, shader stage, builder, where's reflection? Compile inches per v. Yeah, I don't have reflection here. Let's go down again, and there you go. So something like this. Let's grab the reflection and let's store that too. So reflection, and this is just the shader module basically. And there you go. So shader module, well, in fact here it needs the artifact hatch, the binary u8 dot inwrap. Instead of inwrap, can we just say this? No, we cannot. What about context maybe? No. Okay, what about map error? Map error. Well, in fact, let's say anyhow. I guess error maybe. Actually, it's yeah, it's macro. So let's import that macro. Import it, and what's happening here now? Expected in fn1s. About this. There you go. But what is contained in the error? The reflect error. But what this reflect error contains? Okay, let me see. This is stupid. Hold on. Oops, error. It's called error. So there's fmt anyhow kind. What? fmt borrow provide the lower level source of this error, if any. To string. Weird. Oh well, I don't know. Anyhow. Carriage schematic. Hey, any projects in mind, or are you just playing with it? Hello, welcome to the live stream, Scarrig. And I mean, not really any project in mind, I guess. Just pretty much playing with it and learning Vulkan and just sharing pretty much. So yeah, but if you guys have any idea, let me know. I may consider it. Error. Okay, this should be fine, I think. Okay, that's annoying, but anyway. So that's pretty much it for that one, I think. Mismatch type, expected result, shader. Oh yeah, let's actually say okay now, and let's give it the shader itself and the module basically. There you go. And we also want to store the artifact. So shader C compilation artifact, and also we need what else? And honestly, since we have all this crazy properties, maybe we could put it in the struct. But anyways, I've barely touched it myself, though I intend to. Good luck on your first triangle. The API is certainly verbose, but it's not terribly difficult to reason through. I pretty much have done the triangle at this point. Currently, we're just abstracting the shader. But basically, we have done until now. Let me show you. Hold on. So here we go. The first git commit is a triangle. Then we got dynamic rendering. We upgraded to dynamic rendering. We upgraded to synchronization 2 and acquire next image 2. We have fixed --simver, and then swap chain recreation vertex and index buffers and push constants. Abstracted the buffer, and then we got a swap chain fix and the staging buffer. And yeah, and right now we're working with other stuff. Probably soon I'm gonna start working on matrices and you know, basically like model view projection matrices and stuff like that. But yeah, but thanks. So self RVCat. Good. Are your live streams available after the fact? I'd like to run later and view theirs. Yeah, pretty much. There's a lot of videos, in fact, at this point, or live streams, should I say. Let me see. Hold on. I'm gonna give you the playlist. Playlist Vulkan Rust. So yeah, it's been 3 live streams before. Okay, there you go. That's the playlist of all the live streams that are done at this point. So here we're gonna need the actual artifact, and we're also gonna need the shader module. In fact, we already have done that actually. What else? I mean, we'd like to store maybe the source too. Why not? So okay, I guess. Source string. So we got now the source, the module, the artifact. Thank you. I see some of your other topics in vids, and I'm very interested. Glad to hear that. Thanks. So here, in fact, you should make sure to pass in the shader kind. Okay. Now we gotta pass the reflection. Cannot find module in the scope. What? There you go. This should be called module. And this should be called reflection. So reflection. And well, this is gonna be our reflection. And then it's also gonna store. Okay, great. And I think that's it for the shader constructor. So we basically storing the source, we have created the shader module, we've created, well, of course we have compiled it, and we got also the reflection out of it, which is nice. Shader, artifact, and module, and reflection. Okay, so I want to do all this. Right now, interesting. Borrow of moved value path, var value borrowed here after move. Where it's being moved though? Maybe I should say asref here. There you go. Cool. Okay, what else? We could also store the path, honestly. I mean, why not? And for the path, it's gonna be maybe I guess a string, maybe, or path. Let's go with path, maybe. So the set value type you cannot be known at compilation time. Interesting. Can't we store the path? Oh, there's actually path buff. Alright, interesting. Let's go path buff then. And then hopefully we could add the path here. So you could store it. Just in case if we need it. What's happening here? So for example, like for maybe that, like, what is it called? Hot reloading, for example. That would be interesting. Mismatched types, expected path buff, found type parameter P. Okay, how can I actually make it into path buff now? Oops, hold on. I need to tell it first of all path. Then I could say path buff. And then hopefully I could say maybe from path or something like that. The trait bound is not satisfied, is not implemented for path buff, but where it is to express this requirement. From B is not implemented for path buff. Consider introducing a where clause. Well, what about asref, in fact? There you go. Let's go. So yeah, we're storing all of this cool stuff now in our shader abstraction. Associated function u is never used. Let's go. So we're gonna be using it soon. Okay, great. What else? Right now we could even, in fact, right now give it a shader stage. So like shader stage, we're gonna take stuff, and it's just gonna give vk shader stage, hopefully, and we'll maybe pipeline shader stage. In fact, there you go. But in fact, this could be just stage. We already know that it's actually a shader. Expected found. Okay, great. So what's next now? Let's see. There you go. This is how you do it. Hold on. In fact, okay, let's get the module here. The other thing is shader stage flags vertex. Now we have already got that from the using shader kind. I think there should be similar. So vertex is equal to what value? Weird. Interesting. Hold on a second. So if I said shader kind, what we have here? So we could say from turns the argument in changed. Like, do I really have to do it manually? Interesting. Interesting. So honestly, instead of getting, where is that guy? Shader stage. So instead of shader kind, let's call it vk shader stage flags, I guess. No, maybe not. Hold on. I mean, it's correct, but this would actually allow for multiple stages, which maybe we don't want. Interesting. So here's the deal. What we're gonna do is yeah, we're just gonna keep it as it is. Shader C, shader kind, and of course store the shader kind. So that basically shader C, shader kind, and there you go. Of course, we're just gonna pass it right out here. And what's going on here? Cannot find value in the scope. Oh yeah, this could be just kind, in fact. Mismatch types. And this could be a result, I guess. Or it's honestly fine. Create a C string word. Like, why this could fail? Is okay, is error. Well, I'm sure that it's gonna be okay, so let's just unwrap this. Well, I mean, as long as it's actually, well, hold on a second. Vertex module. There's even specialization info. So do we want to hard code this? Well, can we actually say like CSTR maybe, and then like just get a normal string? No, that's gonna be bad. Never mind, let's just go with this. bmain.0, and let's actually build this and just pass it up. Okay, great. And of course this stage, it's kind of clunky. I gotta do this, match the kind, and depending on the kind I gotta map it basically. So self.kind, and basically add remaining patterns. Let's go. Damn. I'm gonna go step by step. For now I only need vertex and fragment, possibly compute at some point, but yeah, I'm only gonna fill these things for now. So vertex, this is gonna be shader stage flags vertex basically, and it's gonna be similar though, just to keep this simple. What we're doing, I think shader kind. Okay, also use shader state flags. They won't collide. Okay, great. Now what we could do is, in theory, like this, and resolved reference y. Oh, to do it like this. So what about now? Oh, it's not a module. Well, that makes sense. So we could only say this, and then we could say this. And otherwise, we're just gonna say unimplemented. Basically. Or we could say to do. Okay. Now this is compute. This is, yeah, vertex. This is fragment. Yep, and this could be just like this. And what else now? Is important redundantly. Okay, let's remove it, I guess. Oops, hold on. If I done this. Okay. If I go up, let's actually remove all these. And let's go down. Okay, great. That's good. So let me just fix the other stuff, like extend 3D, I think. Yeah, there you go. Let's say K. Am I in main branch? Seems like. Okay, what else? Let's see. VK. Okay. Resolve the reference. What? There you go. Yeah, that seems to be fine now. Okay, great. So now let's go back to the struct stuff. So yeah, this should do the trick. Module name. Okay, great. So let's go ahead now and too simply. Now what we could basically do, we don't need this anymore. Let's go down to where we do the shader stuff. Some reasonable things are just haram in Rust. Why? Oh, I see what you're talking about. I see. And hello, Tikinas. Welcome to the live stream. So vertex shader source. So right now, instead of doing all this craziness, what I could say, I could just to say vertex shader to shader, and then I could too simply give it the path. I could give it the shader kind, which is in this case and also I could give it the compiler, which I actually should get here, in fact. And what else? So also I could give it the compile options and the device. I think that's it. Let me make sure to clone this device though. And yeah, that should give us shader. Great. So now I'm just going to do the same thing for the fragment. Just like this. And there you go. Fragment. Compiler, options, device, clone. And yeah, now we don't need this stuff anymore. This stuff too, remove. Constant range. Okay. Push constant range, remove. And now here the fragment shader stages with more. Okay, so here the shader stages. I guess remove these and probably right. Oh my god, how much lines of code. Right. I also don't need these. Okay. Now it's too simply gonna be, well, we do want the push constant stuff. For that, well, we could do a similar thing to the shader stage. Hold on. So fn push constant range. I think just like that. Oopsie, what's happening here? What's that? There you go. And okay. Now the thing is, to get this one, we need some result, isn't it? Okay, let's see. So reflection, oops, self dot reflection, in fact. Okay, dot get push constant range dot in wrap. So get push constant range. Okay. Now if it doesn't exist, because this function may panic, to use pattern matching. Interesting, why this could fail? Maybe like you couldn't find the push constants. Found R speed or V reflect result option. Change return type of method to. Okay, well, let's just give it a result, honestly. Let's give it a result. And then maybe also an option, maybe. What's happening here? Method push constant range must have add missing type arguments. What? Oh, I see. So this should be anyhow result, in fact. Okay, great. Wrong number of arguments. There you go. So now we're just gonna propagate back, hopefully, the error, if possible. And what else? Expected push constant range, found push constant info. And then basically let's try to do something like this, and then this would give us the offset and the size, and we could use that. So let constant range is equal to Rust has been an absolute pleasure to work in, coming from C and C++ world. I'll not dismiss the sheer power and community of C++, but Rust is my hobby language at this point. Yeah, it's pretty great as long as the borrow checker doesn't drive you insane. So far we're good, so yeah. And in fact this guy needs to be mapped. I don't know, it's weird. Anyways, so here we're gonna get the error and we're just gonna convert it into an anyhow error. Though what you guys are working on are like just checking it's harmless. Context. So here we're gonna say, well, honestly, I mean, it should be an option. Hold on, what? No, they shouldn't. Hold on. So result, okay. That's good. And then we got an option. Now basically match I think on this guy. Isn't it? Yep, probably. And what's now? Add remaining patterns. So either it's none or some. So if it's none, well, we're just going to return none. If it's some, constant range or whatever it's called, or constant info, yeah. I want to write the smallest of roguelikes in Rust and Ash, then move to the VR space with OpenXR bindings, or move to bigger Minecraft like worlds in a different project, mini plans, not enough time, the curse of wanting it all. I mean, that's basically all programmers. Well, of course, I'm not talking about JavaScript programmers. Just joking. So yeah, that's basically every low-level programmer. Right, change return type of method, push constant range to option and known. So this would be vacate push constant range builder offset info dot offset dot size info dot size. What now? Dot found option. Makes sense because we gotta say some, or actually okay, we should need to say okay that also this need to be some, maybe. Yep, this needs some. So kind of like I'm just mapping the one strong project I have been orienting to is making a ray marching engine for 4D roguelike. What? There's this fancy projective geometric algebra math that can do 4D stuff easily. Yeah, I've seen some sort of 4D Minecraft. It was crazy. Builder. I found that. Okay. Build. And yeah, there you go. What else there is? There is stage flags too. Oh my god, I gotta do the same thing that I have here. Interesting. So, okay, well, what I'm gonna do with this? Maybe impl from, but I don't think you can actually impl stuff. Interesting. Well, for now, let's just copy it over. I'm not sure what to do with this one. But shader kind and vacate shader stage flags. Honestly, just say vacate, fine, who cares? Okay, vacate, let's go. Variable fragment is never used in reachable pattern. What? Why? Weird. It's not too difficult, but between trying to set up Ash for ray marching, compute and or fragment shaders, the physics engine, and even comprehend the procedural origin, yeah, a bit ambitious. It's not a bit ambitious, it's very ambitious. So let's go. So I think this should be good to go now. Command pool, allocator, vertices, indices, staging buffer, blah blah blah. Yep. Swap chain extension. Okay, now instead of doing this craziness, I could too simply say vertex shader dot push constant range, I think, and of course I gotta wrap all that craziness. Hold on. But found anyhow option. Okay, now let's just say context constant. interesting. How I'm gonna do this exactly? So basically, like, if there is no push constant, hold on a second, what? No, I see. Well, let's just, I think, do something very less. So range equal to be cd new. Essentially, if this guy, well, hold on, let's actually remove this stuff. Create pipeline layout. Oops. Yeah, not all of it. So this would basically be constant ranges, push constant ranges. Let's go. And it would too simply now say push, okay, push constant. Kind of what exactly to do here. Say vertex here dot push constant range. There we go. Ah, oh, I see. How do you do this? I think if push constant range this, maybe some expected bool found. Oh yeah, if let some push constant equal to that, then basically go ahead and add it to the fragment. Well, add the push constant. So I'm not sure if there's a way to do this. Push well, push constant actually. The result reference, what? Oh, that's right. I see. There we go. And there doesn't stop me from hockeying all the avenues I could start with. Yeah, that's kind of like me. Let's some fragment shader. Push constant ranges. Now I wonder if there's some way that, like, if something is none, it wouldn't append it, it wouldn't push it to the But anyway, this should be fine. Now what we're gonna do is just like push constant, push constant. Legit question, because again I have not really touched Vulkan as much as I'd like. Do you cache, store the pipelines, or rebuild them each loop? I've seen both in tutorials and it's rarely explained. Actually, do you cache, store the pipelines, or rebuild them each loop? Now the thing is, in Vulkan you just create the pipelines at the start of your application, like all the pipelines that you're gonna need, and then you just switch between them every frame if you need to. Other than that, I mean, like, you only rebuild a, well, not really rebuild, but basically only build new pipelines if you actually need to, like if you really actually need new pipelines basically. But like if you already know what kind of shaders you want, what kind of parameters you want, etc., then you don't need to rebuild anything. So yeah, watch the site rebuild them every frame, like recreate the pipeline objects. Weird. Nah, that's gonna be so slow. I mean, it takes so long to actually create a pipeline. Well, it does make sense in one case in a tutorial, unless if, like, for example, every time the window gets resized, he's rebuilding the pipeline, maybe for the viewport. Because basically in the pipeline, you basically give it as much information as possible. But there's also dynamic state. Now here in my dynamic state of the pipeline, I set the viewport and the scissor, which means that I don't have to rebuild the pipeline when my window gets resized. But if you don't do that, if you don't specify these as dynamic state, then you basically have to actually go ahead and rebuild the pipeline every time the window gets resized. So, so yeah. Create pipeline layout. Okay. So I think that's it for that one. That makes sense. What's the perf penalty of the dynamic state objects? In modern desktops, pretty much none, or at least almost none. Well, of course, it changes from GPU to GPU, but basically for modern GPUs, it's pretty much very dynamic. So mostly it won't have any effect. In fact, rebuilding the shader is much more expensive because you're basically going to be recompiling the shaders. I know there might be a bit, but as long as it's negligible, yeah, pretty much. But I mean, if you're like, for example, want to use older hardware, then that may be a problem. It may be the case or it may not be the case, essentially. But for modern hardware, and especially for desktops, it's pretty fine. It's like, in fact, we can even add a lot of dynamic states than just the viewports and the scissor. But yeah, create pipeline layout. So we got the push constants now. Nice. What's next? Oh yeah, shader stages now. Here, and let's say vertex shader. Maybe this is terrible, but I'm more than happy to exclude a quarter of a potential user base to ensure my code doesn't have to engage in witchcrafts. That's basically what I'm doing here. I don't really care about Mac OS or any other platform. Like, I just want it to work on my machine, and so it's probably only gonna work on Linux and Windows, basically. Because if you try to go fully cross-platform, it's insane. A lot of cool stuff, like for example, Vulkan 1.3 comes with a lot of great stuff, and like dynamic rendering. There is buffer dynamic address, although I'm not using that yet. But yeah, there's a lot of cool stuff. And yeah, so right now we could just say fragment shader stage and get the stage. Simple as that. Lovely. So that's very cool. Is there anything else we can automate or something? Counterclockwise back. Yeah, seems good to me. Now here we basically need to drop those shaders once we're done with the pipeline. Once the pipeline got created, I mean, we can, or tiling GPUs for mobiles. Trying to grab info from a presentation that focuses on time is kind of difficult sometimes. Yeah, no, mobile, no way. If you want mobile, you probably want to use Android 1.0 if you want to, sorry, Vulkan API 1.0 if you want to support all phones. For example, my phone, it's pretty old. Well, I don't know, like maybe 5 years? Actually, not sure. But currently only have Vulkan 1.0 pretty much. So, but you mostly, if you just wanna like support modern mobiles, probably would shoot for 1.1 basically, or even more 1.2, but 1.3 no way. And for macOS, pretty much 1.2 at this point. I think we're good now. Let's see. Vertex, help to match an environment, qualify the path. Watch. Okay. Shader C, shader kind. There you go, there you go, there you go. I get what you mean. I have no intentions of touching mobile, which is odd because the subpasses architecture in the render pass look useful, but I've seen that you're better off with multiple. I'm not even using render passes and frame buffers anymore. I'm using dynamic rendering, which is core extension in Vulkan 1.3. So you basically don't even need to enable any extension to get it. It's basically in the API itself. Which is pretty cool. So you could just throw render passes into the trash and throw frame buffers into the trash. So that's what I have here. I'm using dynamic rendering, which is very cool, much more intuitive. So yeah, is there anything else? Let's see. Path buff. Okay, great. Great. Other than that, what else we could do? Should we try to do hot reloading? Not really. Or you could still easily support render graph structures with dynamic rendering as well. No? Render graph structures. I'm not sure what you mean by render graph structures. I mean, I kind of know what you mean, but I mean, let me show you the setup of dynamic render real quick on what's going on. So I have no frame buffers and no render pass. And in my pipeline, let me show you my pipeline. There you go. I pass null for the render pass, so no render pass. And I just pass another struct called pipeline render create info. I give it the swap chain format, and that's pretty much it, all I need in the pipeline. And the other thing is, I also have MSAA here, multi-sampling. But anyway, I also don't have any frame buffers, as you can see. Frame graph, basically for highly complex scenes with multiple shader materials, post processing, etc. Some studios use frame graphs, render graphs to build out the graph, rendering for the file. I mean, it should work. I don't know. I mean, you just, instead of creating render passes, you just have to like do begin rendering and essentially make sure you're doing the right, what is it called, the right command pipeline barriers, so you could actually switch the layouts. So basically, instead of that black box that render passes were, right now we have everything explicit, very clear, very intuitive, essentially. So yeah, anyways, so how we can actually support, let's see, hot reloading. I wonder if we can actually support that. Basically, what we're gonna need in that case, we need somehow to make the First of all, we need somehow to actually detect that the shader source code have changed at runtime. And if that happens, or when that happens, we basically need to recreate the shaders and also to go ahead and recreate the pipeline that those shaders or like that depends on those shaders essentially. So like a graph, basically dependency graph. And also what else we need to do? Push constant range, pipeline layout, of course, pipeline layout and stuff like that. Yeah, I think maybe that's it pretty much. Yeah, but you need somehow to make sure that while the new pipeline is building, the old pipeline would still exist until the new one is ready. Otherwise, you're just gonna block the application from rendering, which is gonna be crazy. Alright, thank you for showing this. I was totally prepared to suffer through building render passes. They did look very black boxy. Yeah, they're just pretty much black boxes and just super clunky. I think dynamic rendering is pretty good. So basically, instead of render passes doing the job for you and just making your life harder, you're just explicitly doing what it needs. For example, render passes handles what is it called? Layout switches for images, for examples. But here in dynamic rendering, you have to actually do that manually using command pipeline barrier. Hold on. There you go, using command pipeline barrier. Like here, I'm actually switching the layout of what is it, the swap chain image. I'm switching the pipeline of the swap chain image from indefined to attachment optimal. That's all it takes to do so. And here I'm telling it I need to, before you like destination, before you start, I think color attachment output, wait for the top of pipe. Well, top of pipe basically means waiting for nothing, I guess. Same thing for the MSAA image here. And basically, before I present, I'm just waiting for the color attachment output to be ready. And the destination stage mask is the bottom of pipe. It's like none. Though I could probably use none here, maybe too. Not sure. None. Yeah, there is none. Let's see. Hold on. Top of pipe. None. Not sure that would work. Let's see. Absolutely love that Vulkan gives you total control of synchronization. Async submitting work means more done with less CPU blocking. Yep, that's pretty great. So there you go. It works fine with none, and none is basically the new flag, which is pretty cool. Anyway, so what's we gonna do next now? Handle allocation size. Let's see if there's some hot reloading crates like that could help us with that basically. For fast, well, that's I think for dynamic libraries or something like that. Like, how do you actually watch a file? I mean, hot reloading a file. Rust, of course. If you go full GPU render with multi-draw indirect, and or you go full mesh shader for the number of cards that supports it, you can basically render ridiculous geometry with very little CPU. Yeah, pretty much. That would be cool. Hot reloading Rust for fun and faster feedback cycles. No, this is for code. Live reloading in Rust. Okay, how to check for Rust file watcher or something like that. I could tap into Bevy's hot reload code. I don't know. I'd like a generic library for now, maybe. The set of requirements for watcher event handling functions can deliver file activity notifications. So basically there's this notify. I think this is maybe async. There you go, there's some examples here. So basically you say automatically select the best implementation for your platform. Watcher, recommend watcher, okay, blah blah what. Add a path to be watched, all files and directories at the path, and it will be monitored for changes. Interesting. Watch, recursive mode, recursive. This is probably honestly the task of maybe some sort of asset system, some asset manager system or whatever. But anyway, so let's see what we could do now. Let's go to the tutorial, and let's, I guess, go with this one right now. Descriptor layout and buffer. Bevy uses notify. Interesting. A uniform buffer object. UBO. Great. Okay, so let's go ahead and start doing this. So basically, hold on. First of all, what we have changed so far? We have added reflection. And what else? R spurv reflect shader say. Yeah, we have also abstracted the shader basically. And yeah, that's it. So abstract shader and reflection and reflection. Or should I say shader, abstraction, and reflection. Let's go. My mind is kind of slowed tonight for some reason. Copy this. Let's go to, okay, here. All right, amazing. And now what we gotta do is, well, basically this. So projection matrix, the view matrix, and the model matrix. Pretty cool. Actually, let's leave that. Let's just add these guys. And yeah, that's pretty much it. What this whole matrix is called though? Does it have a name? Like the final matrix, final transformation matrix. I guess transform? Maybe? No, I don't know. Could not check commit internal error to do what? Really? No, it works. I don't know. Anyways, so that's it for the shader. That's what we need. Here we got a vertex shader. There's no difference, I think, isn't it? Yeah, pretty much, seems like. So now we need the descriptor set layout. So GLM, well, for us we're using GLAM. So let's go ahead to our code. Instead of C++, we're gonna go with Rust, of course. There we go. Instead of GLM, GLAM. Let's see if that would work. Field type must be specified. Is it like called something else? What? Weird. Thing is weird here. Hold on. Does this compile? Yeah, it does compile. So what's happening? Okay, struct. Where this is coming from? There you go. Okay. Well, not here. Here. Struct. Oh, I see. My bad. So it's model, glam, mat. Huh? Where's matrix? There's dmat, which is basically, I think, dynamic. And there's also mat4. There you go. So model, view, glam, mat4, then projection, which is glam, mat4. Let's go. Oops. There you go. Model, view, projection. Okay, let's go. Honestly, just call it projection. Why bother? And what else? Yep. Same thing here. Model, view, projection. There you go. Okay. So now we just gotta add these guys. There. And we should be good to go. Now we have already got the descriptor sets from the shader through reflection, so we could use that. So here, what he's trying to create, he's trying to create the descriptor set layout. Okay, let's go ahead and create one, I guess. Where's pipeline layout? There you go. So let's create it here. Let is equal to device create descriptors. Well, that's actually the layout. So that's descriptors builder dot. Okay, great. Now here we got the bindings, which we need. Okay, so here what we need to give it, I think one binding, right? Yep, one binding. Binding count 1. UVO. Well, I don't honestly feel good, so I think I'm gonna end the live stream for now. My mind is super slow tonight for some reason. Gotta go maybe sleep or something. So see everyone, see you in the next live stream, maybe tomorrow. So see everyone, goodbye.